In this video, we're going to learn about centripetal acceleration and centripetal force. Well, what is the definition of this word centripetal? Well, centripetal acceleration and force refers to the center pointing acceleration and force. And that is what the word centripetal means. It means center pointing. And it's the acceleration or the force that causes motion in a circular path. So what we have over here in this picture is a really very important geometry, very, very important for us to know, is that if there is an object moving around its circular path like so, at any instant in time, at any location in time, say for example over here at about 3 o'clock, there is this line called a tangent. And a tangent by definition is perpendicular to a radius. That is the direction at any instant in time. So when we come up to the top here, you can see that the direction of the velocity has changed to the left. And by the time we come over here to 9 o'clock, we can see the velocity is downward. And by the time we get down here to 6 o'clock, it is moving to the right. So what we have is an object traveling at constant speed, but the direction is changing. It's continuously changing. At every instant on the path, the direction is different. So since velocity is speed and direction, even though the speed is constant, the direction is changing, so that means there is a change in velocity. And this is hard for most of us to adapt to, this concept that even when something is traveling at constant speed in this orbit, its velocity is changing because the direction is changing. And if there's a change in velocity, that means there must be acceleration. So any change in velocity means that there is acceleration. And so what is the acceleration that causes this to happen? Well, if you imagine something traveling along this line here like so, what would be the direction of the force that would be applied that would cause that to curve its path? Well, the direction of the force would be this way. And when we're up here, the direction of the force would be that way. And when we're over here, the direction of the force would be that way. So we could see then that there is an inward pointing or center pointing force, what we call a centripetal or center pointing force that causes it to travel in a circle. So we have a centripetal force is any force that causes it to travel in a curved path. And the resulting change in velocity is the centripetal acceleration. The centripetal force causes the centripetal acceleration. So there is a formula for acceleration. It is the speed squared divided by the radius of the circle involved. And so since the force is usually F equals ma, well, since we have a centripetal force, we need a centripetal acceleration. So the centripetal force is simply the mass times the centripetal acceleration. And the centripetal acceleration AC is v squared over r. So when we think about the directions, it is a vector. But what we can see, depending on your framework, we can say that in every case, the centripetal acceleration and the centripetal force are pointing toward the center. So you could say it's got a constant direction, but the direction of the center is different. Here it's to the left, and here it's down, and here it's to the right, and here it's upward. So we could describe it with one word as being inward, but in reality, the direction is changing. But it's always pointing toward the center. Now, it's also important for us to remember that r does not refer to the radius. It refers to the distance between the centers. And the reason for that could be simple. I could say, for example, that we have the Earth like this, and there is a moon traveling around the Earth. And so r is the distance between the centers. It's not the distance from the Earth to the moon, which would be this distance, which would be very different distance. So it's the distance between the centers. So I want to talk a little bit more about the meaning of center pointing or centripetal force and acceleration. A centripetal force is not a new force. It's just an adjective to describe the geometry as center pointing. So centripetal forces could be gravity, could be tension, could be friction, could be electricity, could be magnetism, could be other things. So when we look at the case of a star and its planets, there is a center pointing force. And that center pointing force that's causing this to happen is gravity. It's acting perpendicular to that path, pulling it, that attractive force that causes it to travel in a circular orbit. So the centripetal force is the force of gravity. When we look at the case of this hammer thrower here, there is a center pointing force, but the center pointing force is the tension of the athlete pulling on the hammer cable. So in this case, the centripetal force is the tension. We could also look at a car driving around its path. And this one is not so obvious, but the center pointing force is friction. It's the force of friction that causes it to travel in its path. Now you might imagine that if the road were very icy and you were trying to drive, the object wants to keep its current motion, traveling in a straight line. And the reason it doesn't, when it's icy, or the reason it does keep going in a straight path when it's icy is there's no friction. But once the ice is gone, the tires you can turn, and it requires friction to turn. If there's no friction, you'll go in a straight line. So it's the force of friction that is the centripetal force. We could also, next year we'll study chemistry, and we see there's the nucleus of an atom and electrons going around in this kind of planetary model. We've got positive charges in the nucleus, and we've got a negative charge, the electron. Well, there is an attractive force, and that is the electric force. The Coulomb force is attracting them. And at every location, that Coulomb force is causing them to be attracted. So the centripetal force is the electrostatic force. We can have a magnetic field here, and what this shows is that this diagram shows a magnetic field, and the short of it is this positive charge is acting, the magnetic force is acting this way to bend that positive charge, and it's acting this way to bend that negative charge. So in this case, the centripetal or center pointing force is the magnetic force. So centripetal force is not a new force, it's just something that describes one of these other forces that's causing something to travel in a circular path. So how do we do a calculation from this? Well, we've got an example here. We've got the Earth rotating on its axis once every 24 hours. So there's the North Pole, and we have a person standing on the Earth at the equator. We're looking downward on it. We know it takes 24 hours to travel around. We've got a radius of 6,371.0 kilometers. Hours and kilometers, of course, we need to change to meters and seconds. But we want the acceleration, the centripetal acceleration. So the centripetal acceleration is a squared, AC equals V squared over R. And we know the R is this 6,371 kilometers. Well, we can convert that, 6,371.0 kilometers. And to convert that, put kilometers on the bottom, meters on the top. 1 kilometer is 10 to the third meters. So that is going to be 6,371 plus another 1,000, or 6.371 million meters. Now, the velocity is going to be the distance divided by the time, and this distance it's going to travel is the circumference, which is 2 pi r. And the period, well, we've got that as 24 hours. So 24 hours times hours per minute times minutes per second. 1 hour, 60 minutes, 1 minute, 60 seconds, and we get 86,400 seconds. So 86,400, and we've got 2 pi times 6,371,000, all over 86,400. And when we do that calculation, we get 2 times pi times 6,371, 1, 2, 3, zeros divided by 86,400. And we get 463.3 meters per second. So 463.3 squared. And then we divide that by 6,371,000. And we get 0.03369 meters per second squared. Now, this number is a very small number. It's basically only 3 centimeters per second every second. It's very slow. Well, this is also why we don't feel it. It's a small acceleration. When people say the Earth is rotating, well, how could we possibly be traveling 463 meters per second or 1,100 meters miles per hour? Well, the answer is that's pretty much a constant speed. We only feel accelerations. We don't feel velocity. So this acceleration is small, so we don't feel it. How would we calculate the centripetal force? Well, the centripetal force, let's see, of the Earth traveling around the sun. And there's the Earth traveling around the sun. So the centripetal force would be mv squared over r. And we need the mass of the Earth, which is given to us nicely, 5.9721 times 10 to the 24th. And let's see here. We need the radius of the sun, which is, we have values in kilometers, so we'll have to do some math on that. So 149,598,023 kilometers times kilometers on the bottom, meters on top. 1 kilometer is 10 to the third. And that works out to be 1.49 times 10 to the 11th meters. But we still need the velocity. Well, the velocity is the distance divided by the time, which is 2 pi r over t. And 2 pi times 1.49 times 10 to the 11th. And the time, well, we've got 365.24 days. Well, 365.24 days times, we did this calculation already, 86,400 seconds per day. Is 31,556,736 seconds. So we do the math out on that. By answer, and we get 29,786.1 meters per second. Whoa! 30,000 meters per second. That is 30 kilometers per second. That's about 20 miles per second. That's pretty fast. We're traveling in our orbit around the sun. So 29,786 squared. So square that, multiply it by 5.9721 times 10 to the 24th. Divided by 1.49598023 times 10 to the 11th. And we get a centripetal force of 3.54 times 10 to the 22nd newtons. So that's how we would do that calculation. Now, this centripetal force should be equal to the force of gravity, because the center pointing force that's causing this is gravity. And that's all that we need to know about centripetal force. Perhaps the single most important thing is this geometry, knowing that the velocity is tangent, that the centripetal acceleration and the centripetal force are toward the center. Now, these little arrows on top of this are confusing. That doesn't mean that's the direction. It just means that centripetal acceleration is a vector. So both the centripetal acceleration and the centripetal force are pointing toward the center.